All right, so today we're gonna help you guys out with this workshop with graphing polynomial functions. So I know everyone's been having a fun time in college algebra so far, right? A very exciting time. All right, and so the first page is what we're gonna go off of. All right, and so we have a list of procedures to go through. So the first one is we want to find the x-intercepts, or what we call the zeros now. So the zeros of a function by setting the function equal to 0. All right, so we're going to either use factor or use the synthetic division to find these zeros. So we want to find out what our zeros are and if there's a multiplicity, what that multiplicity is for the zeros. All right, and so we're going to, if it's bigger than 2, like if you have a fourth degree, we'll use synthetic division until we get a quadratic or a second power polynomial. Then you can use the quadratic formula, or we can factor. And the second step, we want to find the y-intercept. So that should be the easy one. You put zeros in for all the x's and find the y. And the third step is by using the leading coefficient. We're going to do a leading coefficient test to see the end behavior of our function. All right, so a nice little graph here to show you the different end behaviors. And then we're going to pick additional points. All right, so we're going to have the zeros, the y-intercepts, and then to see how high or how low the graph goes, we're going to pick points in between our zeros. So we're going to find the midpoint of these points. And then the last, step 6, is we're going to graph. All right, so let's get started with the first one. All right, so step 1, right? So the first step says to find the x-intercepts. So we're given a function, negative x to the 4th power plus 2x cubed. All right, and the first step set to find the x-intercepts, we set f of x equal to 0. And the first thing I'm going to do is factor if I can. Can I factor this? Yes. Yes, I can factor it. So here I have 4 x's and here I have 3 x's. So what I'm going to do is I'm just going to factor out, well, I don't like having a negative here, so I'm going to factor out a negative x. So I'm going to factor out negative x cubed. Is that okay with everybody? All right, so I factor the negative from here, so this becomes a positive. I took 3 x's out, so I have 1 x left. I factored a negative out of this guy, so he was positive, now he's negative. I factored out 3 x's, he had 3 x's to start, so all he has left is his 2. So this one's kind of nice because I'm essentially done, right? I don't need to do synthetic division. The next thing I do is to find the zeros, is just set them equal to 0. All right. And x minus 2 equals 0. Do I really need to look at the power for this guy? No. No. So I can just look at the negative x. So negative x equals 0, so my 0 is going to be 0. All right, I solve this guy. I add 2 to both sides, so I get x equals 2. So my 2 zeros, so maybe we'll do a little try here. All right, my 2 zeros are 0 and positive 2. And now I want to look at the multiplicity. All right, so 0 has a multiplicity of what? So if I look here, 0 came from the negative x cubed, right? Yes. So it means it has a multiplicity of 3.
Why is it x minus 2 in the parentheses?
So here, I factored out the negative. And so this was a positive, so it became a negative.
So you could just use the negative, just come to negative?
Mm-hmm. All right. And then for my 2, the 0, that's a 2, what's my multiplicity?
1.
1, that's right, because it's like a little unspoken. We don't really write the 1 there, but there's a 1 hanging out there on the top. So I have a multiplicity of 1. All right, awesome. And so my next step is I need to find the y-intercepts. Maybe I should have thought about how big I was writing. All right, so I have my zeros and I have my multiplicity. So next I want to find my y-intercept. So to find the y-intercept, I find f of 0. So I plug 0 in for all the x's. So I have negative 0 to the 4th power plus 2 times 0 to the 3rd power. All right, and so what's this going to give me?
0.
0, right? 0 to the 4th power is still 0. 0 to the 3rd power is still 0. 0 times anything is 0. All right. So now I know that here I have a point 0, 0. All right, so now let's look at, I found the y-intercept, so I have the x-intercepts right here at 0 and 2. I have x-intercepts, y-intercept at 0. Now I need to determine the end behavior. All right, and so and according to the instructions, we use the leading coefficient test to determine the end behavior of a polynomial. All right, so if I look back here at the original function, this is the leading term because it has the highest power, and the coefficient in front of it is negative. All right, so and the leading power is even, right? So the leading power is even, and and the leading coefficient is negative. So if I look at the chart, which one of those satisfies the end behavior? So back on the first page, I look at the degree. So the degree is even, right? So I'm going to use this first column. And so the leading coefficient is negative, so I go down to the second row, first column, second row. So my end behavior is going to be something like this. All right, so I know it's going to point down, and it's going to look kind of like a parabola. The end behavior is going to be like a parabola. So it's going to be pointing down. Yeah, I think I'm going to be using the whole board for this. All right. So the next step, and the last step before we graph it, is I want to find some additional values just to kind of help me sketch the graph. So the points I have are the x-intercepts at 0, 2. I have a y-intercept at 0, 0, but that's the same as this point right here. So I need to find just a couple extra points. So let's do a little. All right, so this is just for the additional points. So the points I know we have, I have a point when x is 0, y is 0, and I have a point when x is 2, y is 0. So I'm going to pick points around all three of these guys. So let's pick 1, -1, and 3 and see what happens. All right, so my function at -1 is going to be -1 to the 4th power plus 2 times -1 to the 3rd power. So when it's an even power, what happens to -1? It becomes positive. And when it's odd, it stays negative. So this is still -1. And 2 times -1 is -2, which is -3. All right, cool. And let's do the same thing for 1 and 3. All right, so f of 1 is going to be -1 to the 4th power plus 2 times 1 to the 3rd power. -1 plus 2, 1. All right, and next we're going to do the same thing for 3. So let me make some space. All right, next we're going to find f of 3. All right, so it's going to be negative, and this is going to be a very big number. Maybe not. We'll find out. This is negative 81 plus 27 times 2, 54. It's still a pretty big number. Negative 27? Okay, thank you. Yeah, so that's a really big number. So we'll kind of guesstimate on the graphing part. All right, so now I have all my points, all right, in a nice little table right here. So I'm going to go to my graph. I'm going to just plot them, all right? So negative 1, negative 3. So I go negative 1, negative 3. I have 0, 0. I have 1, 1. I have 2, 0. And I have 3, 27. So it's just going to take a really, really steep dive. And once I have all my points, I'm just going to connect them with a smooth curve. So let's just... And this guy is just going to shoot down like that. All right, so this one we didn't have to do anything fancy with synthetic division, but is everyone okay with following the steps so far? All right, so the first thing we did was we found the x-intercepts. All right, then we found the we found the x-intercepts and their multiplicity. Then we found the y-intercepts. Then we found the end behavior, and then we found additional points. And I just threw them all into one t-table. All right, so any question or confusion on this part? And this time I'll write a little nicer. I'll start on this side of the board and work this way, so it's not everywhere. Let's see. All right. All right, so let's move on to something a little more fancy. All right, so for the second problem, we have x cubed plus 3x squared minus x minus 3. Did I miss one? Oh, I did. Okay, I turned one upside down on accident. Oops. All right. There we go. So not this guy. That'll be next. Is it the x minus 1 cubed? Yeah. Okay, yeah. I'm sorry, I don't have mine stapled, so mine, I guess I just turned over one I shouldn't have. All right. All right, so now we're going to graph this guy. So do I have to factor him? No, this one's the nice one, so it's already factored for us. So can I find, so my first step is to find the zeros, right? Can I do that right away? I can, right? So what are my zeros?
1, 1.
All right, so 1 and negative 1. And what are their multiplicities? Okay, so for the 1, I have a multiplicity of 3. And for the negative 1, I have a multiplicity of 2. All right.
For 1, it's 2. For negative 1, it's 3.
Once you
No.
put zeros.
So these are the zeros, right?
Okay.
So remember, to find the zeros, you just take the inside part, and we set them equal to 0. Right, so this one will give me x equals 1, and this will give me x equals negative 1. So negative 1 belongs to this guy, who has a multiplicity of 2. And 1 belongs to this guy, who has a multiplicity of 3. All right, so last time they both had the same multiplicity. No, they didn't. They had different. Yeah, they both had odd. But now we have one that's an even multiplicity. So in the last graph, the lines cross through the x-axis. So if you have an odd multiplicity, that means our line's going to cross through the x-axis. But if I have, so this is odd. If I have an even multiplicity, it's going to touch it, and it's going to bounce back. So if it's on the positive side, so if here's the x-axis, so because it's even, and here's my 0, if it's on a positive side, it'll come down and bounce back up. Or if it's on the negative side, it'll come up and bounce back down. All right, so that's important to know for graphing, is whether or not these are even or odd, and what happens when they are. All right, and so we don't have to rationalize it. We found the zeros already. So the next step is, so this is step 1. So step 2 is to find the y-intercept. And the y-intercept is when we set x equal to 0. Okay. So I have 0 minus 1 cubed and 0 plus 1 squared. All right, so I get negative 1. All right, is that all right for everybody? Let's clear all this stuff. All right. In step 3, I need to look at the end behavior. All right. All right, and the two things I need to look at is the leading coefficient and then the highest power. So what is my highest power here? That's right. Well, but so here I have 2, 3, 5 is odd. 1 second, having a brain fart. 3. Okay, so remember, so these are all connected through multiplication, right? So eventually I'm going to have, like if I wanted to see the whole polynomial, I would have to keep foiling and foiling and foiling. And so since these are connected by multiplication, to find the highest power, I'm going to add all the exponents. So it would be 5, right? I guess in this case it wouldn't matter because you have a 3 here. So it's still odd. But I know that the highest power. So did your teacher tell you all to look at this, the highest exponent here, or look at think about multiplying it out? Just highest exponent? All right, cool. So let's look at the highest exponent. So 3. So my highest power is 3.
But you do add them?
You can, yes. I'm trying to think of a counter-example here. If we run into that issue later on, I'll bring it back up, but for now, let's just look at the highest power.
Okay.
All right, so the highest power is 3. And so we know which is an odd number. And look at the leading coefficient. And so in this case, you look at the number outside of the parentheses. Do we have anything here? No, right? It's just a positive 1. So since it's positive, and we really don't care about the number, we just want to know the sign. So on the outside, it's positive, so that's good for us. All right, so if it's odd and positive, what does that tell us about the end behavior? That's right, the different things. One's going up, one's going down, but in this case, it's going to start in the bottom, and it's going to go up. All right, and we can refer back to the chart, and we'll see that if it's positive and odd, the left is going down, and the right is pointing up. All right. Number 4, we want to just pick some extra points, all right, to help us graph. So we can have a smooth, continuous line. So what points do I have already? I have 1, 0. I have negative 1, 0. That's right, and I have 0, negative 1. So these are some nice points, right? I have a point in between these two. So let's pick a point on either side, like negative 2 and 2. Sound like good numbers. All right, so I plug in 2. Into my function, so negative 2 might be interesting. Well, this one will be okay. So 2 minus 1 is 1. 2 plus 1 is 3. So I see 9. And then f of negative 2, I have negative 2 minus 1 cubed, and then negative 2 plus 1 squared. This is negative 3 cubed, negative 1 squared. So 1 times negative 27. All right. So these points okay? All right, so I have negative 27. It's another big number we can't graph. All right, so now that I have my table of points, I want to go ahead and go to my graph and just let's plot the points. So I have 2, positive 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 1, 0. I have 0, negative 1. I have negative 1, 0. And then I have negative 2, 27. So it's just, I'll just put a point way down here. All right, and so at 1, we have an odd multiplicity. So I know that my line's going to go through the x-axis. And at negative 1, I have an even multiplicity. So I know that my line is going to bounce. All right, so I know it's going to come up and bounce. So because 1 has an odd multiplicity, it passes through the x-axis. And because negative 1 has an even multiplicity, it's going to bounce on the x-axis. All right, and so I just connect the dots. You want to make one smooth, continuous line. And then this one will just drop like a roller coaster. And then there's our beautiful line. All right. Cool. So any questions on this one? All right, so are we okay so far finding the x-intercepts, finding the y-intercept, finding end behavior? And so remember, if you have trouble with the end behavior, always look at that first page. We have a nice little chart that shows you what the end behavior should look like. All right. So now we get to do the fun one. So on the first page, it talks about using synthetic division. If you have powers higher than 2, because we don't know how, we can't really factor them, so we use synthetic division to break it down. That's also called the rational zero theorem. Oops. And so here we're given a polynomial that, well, okay, I say it can't easily be factored, but I just made a liar of myself. Can I factor that? How about, anyone think back? So when you have 4 terms in factoring, I can factor by grouping, right? I should know better too, because all the 0320 students are doing factoring right now. So what's the GCF here? X squared. The GCF here is? -1, right? So we're factored by grouping. You want the 2 inside parts to be the same. So if these both are positive and these are negative, I can factor out -1 to make them positive. So Kurt gave us some nice ones. Right, so this one worked out pretty nice. I can bring the x plus 3 out. I have x squared minus 1. Can I break this down further?
Yeah.
That's right, difference of 2 squares. That's right, and I was lazy, I didn't write this all the way down. All right, so f of x is equal to x plus 3, x plus 1, and x minus 1. So what are my zeros? That's right, so it's 1, -1, -3. And the multiplicity of each of them is 1. All right, so multiplicity of 1 on each one. Awesome. So this one wasn't as interesting as I thought it was going to be.
What's the multiplicity once it's factored?
Yes. Yes. That's right, look for the multiplicity once you have it broken down. All right, so once I have my zeros, next step is let's look for a y-intercept. So I can use this guy for my, well, I can use either one for my y-intercept. And then we plug in 0 for x. So I'm going to plug in zeros for all these x's. So I have 0 cubed plus 3 times 0 squared minus 0 minus 3. So that leaves my y-intercept to be what? Minus 3, right? That's an awful 0. That's better. Remember, because all these guys go to 0, and all I have left is that minus 3 at the end. All right. All right, so now the end behavior. Look at the highest power and the leading coefficient. All right. That's right. So, but the highest power is odd. Right. So the highest power is odd, and the leading coefficient is positive. All right. So odd and positive. That was just like the last one, right? Odd and positive means it kind of looks like the cubic function. It's going to have the end behavior. It's going to come from negative infinity and it's going to shoot up to positive infinity for the range. In the fourth step, let's graph some more points. So what points do I have currently? Yeah, so I have all these guys right here, right? So let's do 1, 0, -1, 0, -3, 0. And then I have 0, -3. My last step is now I need to pick points around here to get an idea of what my graph is doing. All right, so let's pick like -2. Oh no, that's +2. Here we'll do -2 and -4. All right, so let's plug these into the function. I'm going to use this guy. He looks like it might be a little easier to use. So 2 plus 3 is 5. Just this right here, the factored function. 2 plus 1 is 3. And 2 minus 1 is 1. So at 2 I have 15. So negative 2. Negative 2 plus 3 is 1. Negative 2 plus 1 is negative 1. And negative 1 minus 1 is negative 2. So that gives me positive 2. All right. And I have negative 4. So negative 4 plus 3 is, oops, let me write this out. So remember, I'm just using this guy right here. So negative 4 plus 3 is negative 1. Negative 4 plus 1 is negative 3. And negative 4 minus 1 is negative 5. So 3 negatives give me a negative. 5 times 3 is 15. So over here at negative 4, I have negative 15. All right. Is everyone okay with this?
It lost me a little bit over there. Lost me a little bit with that.
With this?
Yeah, just a bit.
Okay, so for these guys right here, all I did, I took the factored function and I just did, so this is, I plug in 2, so 2 plus 3 times 2 plus 1 times 2 minus 1. And so 2 plus 3 was 5, 2 plus 1 is 3, and 2 minus 1 gives me the 1. Yeah. And so I just did that for all of them. And what are you confused on?
No, I was just saying, when we get step 4, where do we get the zeros from?
So these are my zeros, right? So these are zeros are the x value of the x-intercept. So these are, because remember, 0 and x-intercept are the same thing, except one's a point and one's a number. And the coordinate for these would be 1, 0, because the y value would be 0 at that point. All right. So any other questions? So I mean, you don't have to use this. You could use the first one as well. That one just would require a little more work. All right. So next step, I'm just going to plug in all my points. All right. So I have 2, 15. So at 2, 15, let me just way up here. I have 1, 0. I have 0, negative 3. I have negative 1, 0. Negative 2, 2. And negative 3, 0. And then negative 4, negative 15. So negative 4 and negative 15 is just way down here. All right, so the end behavior tells me that I'm going to start way down here at the bottom. I'm going to come up, and my last point is going to shoot up. It's going to go upwards. All right, so I'm going to start down here. Go up, down. And go up. You just want to do one smooth, continuous line. All right, and so we see that all these all the zeros, they cross through the x-axis, right? So the multiplicity of all of them is odd. Remember, odd multiplicity means you cross through the x-axis. All right. All right. And is everyone still okay with me just plugging it into here? Using that right there? Okay. All right, so any questions on this one? Or any other questions? All right, so let's go on to the next one. Okay, so our new function now is x to the 4th power minus 4x cubed minus 3x squared plus 10x plus 8. So can I factor this using my grouping? No. So sadly, I can't do that anymore. So now how do we learn to break down polynomials? If we can't factor it, quadratic formula it, or complete the square, what are we stuck with?
Synthetic division.
That's right, we're stuck with synthetic division. Let's redefine your P and your Q. All right, so the P is the coefficient of the first term, which is plus minus 1. And your Q, we want to list out all the factors of 8. So all the factors of 8 are plus minus 1, plus minus 2, plus minus 4, and plus minus 8. And then we look at the ratio to find out what we need to divide by. Look at the ratio of Q over P. And if I divide all these by 1, I'm just going to get all these numbers again. Right, 'cause the only number I have here for P is 1. So all the numbers I get to pick from are all these guys.
Where did Q come from?
So Q is the factors of the last number.
Factor of the last one.
That's right. And P are the factors of the first coefficient. So the first coefficient's 1, 1 only has a factor of 1. And Q is 8, so all the factors of 8 are 1, 2, 4, and 8. All right, so we take the ratio of Q over P, since if you divide anything by 1, you get the same number back. So that one's no problem. And so now we're going to do synthetic division using all these numbers. All right, so remember when you list synthetic division out, you want to list all the coefficients. So we have 1, 4, -3, 10, and 8. In this little box here, I'm just going to start guessing. It's kind of like guess and check. You're just going to guess and see if you end up with a remainder of 0. And so it's always useful to start off with 1. 1's the easiest. And -1 usually works out pretty well.
Is that 4 supposed to be negative?
Which one?
Yes.
Oh, it is, yes. Good catch. I would have gotten that. Completely wrong. All right. So for synthetic division, we drop down the first number and then multiply. So -1 times 1 is -1. I add. I multiply. So positive 5. So then I add again. I get positive 2. I add. So -1 times 2 is -2. 8. Multiply. So you're right, -1 does work out a lot. All right, so -1. And if we hadn't gotten a remainder of 0, I would have had to pick another number and then start over again. And repeat this process until I get a 0 here. So that means one of my factors, so this, if the 0 is -1, that means my new function is going to start, well, the factored form of this function is going to be x plus 1. All right, so there's my first factor. And if I look here at this new function, I still have an a at the end, right? An a here. So all of my divisors could be any of these numbers. So now I want to keep breaking this guy down. All right, so I'm going to use, let me do this off this side. Let's do this here. I don't want to confuse anybody. All right, so now I need to pick new divisors to keep breaking this guy down. So what number should we pick next? I want to pick, let's do positive 1. So I drop the 1. 1 times 1 is 1. Negative 4. Yeah, so this one's not going to work. And 2, and I get 6. So I didn't want that. I need to pick something else that'll give me a 0.
From the cubes, right?
That's right, from the, yeah. Yeah, or from this guy right here. Yeah, from the, guess you get from the cubes, doesn't matter. All right, let's pick 2. All right, so drop the 1. 2 times 1 is 2. 2 times negative 3 is negative 6. Hey, this one looks like it's going to work. Excellent guess. Or did you know? No. All right. All right, so now, what kind of function is this? When there's only 3 terms? It's a trinomial, and it's a quadratic, right? And so, all right, getting ahead of myself. So this is my other factor.
X negative minus 2.
That's right. So my other factor is x minus 2. Okay, and so now that I have this guy from my synthetic division, I can factor this guy, right?
Minus 2. It was a negative.
So this one is x equals 2, right? And when we set the 0 equal to 0, we have to solve for x, right? So this is already solved for x. So if I work backwards, so I subtract 2 from both sides. This is the factor we set equal to 0. All right, so this, if I set this guy equal to 0, I'm going to get 2. All right, so what 2 numbers multiply to give me negative 4 but add to give me negative 3? About 1 and negative 4. Right? And so these are my other 2 factors. Minus 4. Cool. All right. And so I have repeats of x plus 1, right? So I could write this as x plus 1 squared, x minus 2, x minus 4. So this is my function in factored form. All right, and so remember in the beginning when I said that you add up all the powers to get the highest power? We'll get the highest power here. What happens if I add up all the powers here? Okay. So if I were to FOIL this out, I would get this guy, right? And so that's what I was talking about earlier.
Okay.
All right, but then it turns out here the highest power is even. This one's even. So I'm still trying to think in my head of an example when that would work against you. But if not, like come to the lab, I might have something later. I'll try and think. If not, I'll post something about it. Let me make some room. Okay, so now we have our function in factored form. What are my zeros and what are their multiplicity? Yeah, so negative 1, 2, and 4. And negative 1 has a multiplicity of 2. And 2 and 4 both have a multiplicity of 1. Excellent. All right, so that was a long first step, right? All right, so now I have step 2. Find the y-intercept. All right, so I can plug zeros into all those x's. If I do that, what am I going to end up with? So can you look at that and tell me what I'm going to end up with? Just a, right? Or I'll write it out. I'll write it out. No worries. So what happens to all three of these? They become zeros, right? And then all I have is an 8. So f of 0 is equal to 8. Step 3, let's look at my end behavior. All right, so the end behavior, well, the highest exponent is even, right? And the leading coefficient is positive. So what is my end behavior going to look like? That's right. Goalpost going up. Okay, final step. Let's plot some more points. All right, so far the points I have are negative 1, 0. I have 0, 8. I have 2, 1. And I have 4, 1. Okay, I don't know why I said 1. 2, 0, 4, 0. I know why I said 1, because I looked at the multiplicity. But the 0 is 4, 4, 0. So I need to pick points around. I already have a 0 in between negative 1 and 2. So I need to pick something like negative 2 here, pick a 3 here, and a 5 here. All right, so I'm just going to use the factored function. So f of negative 2. All right, so if I plug negative 2 into this guy right here, what's negative 2 plus 1? That's negative 1, right? So I have negative 1 squared. Then negative 2 minus 2 is negative 3. And negative 2 minus 4 gives me negative 6. I have positive 1, and negative 3 times negative 6 is 18. So I get 18. So let's do the same thing for 3. 3 plus 1 is 4. So I'm at 4 squared. 4 minus 2 is 2. 4 minus 4 is, oh, wait, I'm not doing 4, I'm doing 3. I'm crazy. All right, 1 second. 3 plus 1 is 4. 3 minus 2 is 1. Okay. And 3 minus 4 is negative 1. Okay. So 16 times negative 1. 5's not going to be much better. Okay. All right, f of 5. I'm going to plug in 5 for all the x's. So I have 6 squared. So this got ridiculous pretty fast. 5 minus 2 is 3. And 5 minus 4 is 1. And this number is too big to fit on that graph. 36 times 3 is 118. Or is it 108? No, 118. Yeah. Okay. So we have our points. And if you need to head out, just make sure you fill out the review and throw it right next to the sign sheet. Do you have to go right now?
Yes, sir. We have class in like 5 minutes.
Okay.
Yeah.
No problem. Sorry. I apologize for running over time.
It's fine.
Yeah. Oh my.
No, they're in.
All right. Yeah, so they're in the collegiate high school. All right. So let's graph these points real quick. So I have negative 2, 18. So way up here. I have negative 1, 0. right there. I have 0, 8. 6, 8. I have 2, 0. I have 3, negative 16, so just way down here. And then I have 4, 0. 3, 4. And then I have 5, 118, so 5 is way up here. All right, so points are everywhere. And what is my end behavior supposed to look like?
Both pointing up.
Goal point's going up, so I know I'm starting way up here. And I need to loop down, right? And what's the multiplicity at -1?
2.
It's even, right?
No.
Yeah, it is 2, right?
1, wait.
At -1.
Neg.
Yeah, so -1 is 2, right?
Yes. I don't know.
All right, so yeah, so because our x plus 1 is squared, so the 0 here is -1. And so we multiplicity 2, so I know it's going to bounce here at this guy. And then because these two are odd, it's going to pass through them. And behold my masterpiece. Something like that.
So the zeros are also our solutions.
That's right. Yeah, so they gave you this and they said solve, that means they would just want the zeros. Holy cow. Okay. All right, and so I think that'll wrap up the workshop. We just ran out of time. Yeah, and if you want to do that last problem with me, I'll be in the math lab. I don't know how busy it'll be, but we can.
Same as this one?
Yeah, it'll be the same as the one we just did. We have to do synthetic division.